In this video, I want to talk about our multivariable notes. We've been looking at an equation, I equals V over R, which relates current, voltage, and resistance in an electrical system. But we're going to see that there are other things that are related in a way that can be written like this as well. And so we want to talk about some things that are common to them and how we might more quickly figure out the different ways we can write this equation and how those variables are related. For any equation with three variables that is of this form, there are three different ways that we can write this equation. Ohm's law, which is what we've been looking at, represents the relationship between voltage, current, and resistance, is given this way, but it can also be written in two other ways. So we can write it as V equals IR, or R equals V over I. These all mean the same thing, they just look different. Within these relationships, different variables are going to be related directly, and some are going to be related inversely. So there's a couple of different ways we can think about why that might be, or how to know which is which. One way we can do that is to go back to our equations. So I equals V over R. And if we think back to what it means to be direct and inversely related, if we're just thinking about current and voltage, so these two variables, both of these variables are on the top of the equation, so current and voltage. These are always going to be directly related. So anytime you have variables on opposite sides of the equation and they're both on top, they are directly related. If one goes up, the other will also go up. If we're thinking about these two variables, current and resistance, these are going to be inversely related. And this looks like our model of inverse relationship, right? Y equals K over X is what I was going for there, K over X. Where my variable, I have one on top and the other is on bottom, right? So that's one way you can think about direct and inverse variation. So if you want to use this model, you can look at any of the equations to do this. So this first one that we looked at shows us current and voltage, so that's actually our first question. If we look over at our model, we can see that those are directly proportional. And current and resistance is also shown in this other model, and we said that those are inversely proportional. Now, if we want to find voltage and resistance, which is our last one here, so this is saying voltage is somehow proportional to resistance, I just need to pick any equation where they're on opposite sides. So we could use this one, V equals IR. So voltage and resistance are on opposite sides. They're both on the top. So this means they are directly proportional. So that's one way to think about direct and inverse. And I'm going to show you another way in just a moment when we write our rule diagram. So the rule diagram is a triangle. It looks like this. You might have seen this in another class. Something like this is often used in chemistry. And how we write this is we can look at any of our three versions of our equation. Okay, we can look at any of these. I prefer to use this one when writing the diagram because that allows me to put the V on the top, I and R in the bottom. And so how this works, as I'm doing this, what we want to do is you want to think about, if this was paper, I would use my thumb and I would just cover this piece of my diagram. So when I cover V, that tells me that V is equal to I, and since they're right next to each other, IR, it's V is equal to I times R. And that's the idea I used when I created this diagram, but I could have used any of my other equations. Notice, now if I cover I, this shows me the equation for I equals, and I equals V over R. So I equals V over r as another one of our equations, and that is here, right? And I could have used this to set up my diagram as well, because I know that v has to be over r in the diagram, and then I would be the last spot. My third equation, if I cover this one with my thumb, if I cover r, that gives me the equation r equals v over I. R equals v over I. And those are my three equations that I can get from this diagram. And another thing in this diagram, once you have it set up this way, you can always tell direct and inverse, because these two variables, v and I, so the two on this side are directly proportional. The two on this side are directly proportional, so v and r. And then the two on the bottom, I and r, are inverse. So I and r are inversely proportional, and then the other two pairs are directly proportional. So this is a second way that you can use this diagram. So you can use it to find all the equations, you can use it to tell if they are direct or inverse. Final new piece of this is this language. So when you are asked to write, so I'm looking here now, if we are asked to write a formula that expresses v as a function of r and I, what that means is we want an equation that is v equals something, and you probably want to say where the right side, where the right side includes r and I. So when we say v as a function of r and I, we want v equals something with r and I in it. So in the case of our voltage situation, we would be looking for this equation right here. This would be writing v as a function of r and I. This last one is something that I ask students to give a try themselves. So we're creating a rule diagram for v, b, and h. So if you're watching the video and just doing this for the first time, pause the video now and see if you can look back at our equations and figure out how to create a rule diagram for this equation where volume is equal to base times height. So in order to create this diagram, we have our triangle, and since I've got v is equal to b times h, b times h, b and h have to go in the bottom, b and h, and then v has to go up top, so that when I cover v, I get v is equal to b h. It's important to note here that it doesn't matter which order these are in. I could switch those and my diagram will still work. It might be helpful for you to also write down direct, and inverse, right? That's how these variables are related in this situation.